The next concept I want to tackle is closure. This may be one of my favorite features of JavaScript, and it is definitely critical to understand. Closure is sometimes seen as one of those mysteries of JavaScript. I still remember when I first grasped the idea of closure. It was an aha moment for me. And since being able to grasp that, I've been able to see how much it is used within JavaScript, and also I've been able to apply it to solve certain problems. So closure is not a new construct. It's simply a concept that's used to describe what's possible within JavaScript. And by understanding it, it opens up possibilities for you that you may not have thought of in the past. And it enables you to understand JavaScript code that is frequently being written out there. So let's take a few moments and demystify the whole idea of closure. Now, closure is closely related to scope. So I want to define scope briefly as a starting point. JavaScript uses function scope, meaning functions determine the scope of items that are declared within that function. And scope basically refers to the rules that determine where within our program, the program we write, variables and functions are accessible. Now let's define closure. I've gathered 3 definitions of closure that we'll look at first, and then we'll look at several examples. First off, this comes from javascriptkit.com. A closure is the local variables for a function kept alive after the function has returned. So what it's saying is when a function is finished, those variables are still accessible. Another definition. Closure is when a function is able to remember and access its lexical scope, even when that function is executing outside its lexical scope. Now that definition comes from Kyle Simpson. He wrote the book Scope and Closure, which is a great book for defining both of the and understanding both of those terms. And third, a closure is a function having access to the parent scope even after the parent function has closed. That's from W3C Schools. So in these definitions, it talks about code executing outside of a scope and yet still having access to that scope. That's the commonality of those definitions of closure. So let's jump to some code and begin looking at some examples. Now, in this code, func2 is inside of the function funct. It is part of the scope of funct, whereas we see the function funct3 is completely outside of that scope. Func2 does have access to the scope, but it's executing inside that scope because it's called as the very last thing, so it executes before this function has completely finished. So it illustrates scope, but perhaps not closure if we were to get really technical about it. So let's make a change that will show closure. And a great way to do that is with callbacks. Callbacks are definitely functions that execute outside of the scope. So I'm going to enter set timeout, and I want it to execute func2 after 1 second. Now, if you're not familiar with set timeout, this is a function that allows you to call and execute code after a certain length of time. It takes 2 parameters. The first is the code that will execute. Usually that is entered as a function, normally as an anonymous function. In this case, we are just calling a function. And the second parameter is the number of milliseconds that should wait before it calls that code. in this case 1000 milliseconds, 1 second. So when we call this, it will set up the scope, it will set up this function, and then it will call set timeout. And at the time, right after it calls set timeout, this function is done, it closes, it's no longer running. However, a second later, it then calls a function that was part of it. And that function right here then has access to these variables because it retains that access to the scope, even though it's executing outside of that scope. So let's save that. Open the console, and we'll go ahead and refresh and execute it. And 5 appears. So we get a pause of a second, and then 5 appears. So that first function is already closed. It's done. It's executed. But we then, through the set timeout command, call back to that function that was defined inside that scope. And it still has access to its parent scope, and it can add those numbers together. So one example of closure. So the way we would describe this is funct2 closes over the scope of funct and continues to have access to it. That's where the term closure comes from. All right. Another example, I'm going to go to a different page where I've got 2 buttons created. I'm going to use this as an example. This will also use callbacks, but we'll use this with an event handler. I'm going to paste in some new code. So here we've declared a function counter. Inside of that, we've declared a variable CNT, which we're going to use for simply counting. And then we have accessed the 2 buttons which are on the page. They have an ID of item 1 and item 2, and so we've grabbed those so that we can add an event listener to them. We've then declared a print function, and that simply logs the value of this variable to the console. That's all it does. To each one of those buttons, we've added an event listener, and the function for the code they will execute is count1 for the first one, and that simply increments the CNT variable and then calls the print function. And then count2 for the second one, it does the exact same thing. Now when we call this function, it will execute and it will complete and it will finish. However, when we click on the button, they will still have access to this variable and to this function, even though that function has finished. Now one way to show this working would be simply call the counter function at this point. But what's commonly done when you have a function set up that you only want to execute once is simply to immediately invoke that. So the way I would do that is put parentheses after the function definition. Now since we're going to immediately invoke that, I'd remove assigning it to a variable. I'll put parentheses around it. We now have an immediately invoked function expression. But the real concept that we want to convey here is closure. That even though this function immediately invokes and finishes, function count1 and function count2 will still have access to the scope that was created by function counter. So it will have access to that, and it will have access to the print function as well. So let's take a look at that. Save that. Refresh. Click on one button, and as we can see, it increments and prints out a 1. Click on it again, increments it again, prints out a 2. So it keeps, that variable is keeping track of the value. Even if I click on a second button, which executes an entirely different function, it still retains that value and increments it by 1 because they both have access to the same scope. So jumping back and looking at that code again. So one way to describe this is that count 1 has closure over the scope of counter. We could say that about count 2 as well. Or another way to say it is count 2 still retains a reference to the scope of counter, and we call that closure. All right, one additional JavaScript pattern that illustrates closure very well is the module pattern. Now, that very pattern is what I plan to discuss in the next topic. So let's go ahead and move on.